They call it Bird Dot, a bright red glow in the depths of the cosmos discovered by the James Webb Space Telescope. Not a star, not a galaxy, but a feeding black hole wrapped in gas and dust, and it challenges everything we thought we knew about the early universe. October 30th, 2025. The journal Astronomy and Astrophysics publishes the discovery of an object cataloged as BIRD, Big Red Dot. A research team led by Federica Loiacono from Italy's National Institute for Astrophysics identified this object in archival data from the James Webb Space Telescope. Not by chance, but through systematic analysis of an already well-studied region of sky. The area around quasar J1030 plus 0524, 12.5 billion light-years distant, observed by the Hubble Space Telescope, by Spitzer, by ground-based observatories, cataloged in X-ray data, in radio data. And yet no one had seen BIRD. That changed only with Webb's near-infrared camera, NIRCam, built to see through cosmic dust, to reveal what remains invisible in optical light. There, in the calibrated infrared images, appeared a bright point, compact red, a point source that appeared in no previous catalog. "We noticed BIRD," Loiacono said, "a bright point-like object, but it wasn't a star, and it didn't appear in the existing X-ray and radio catalogs." The question was, what emits infrared radiation but no visible light? What glows red but doesn't appear in X-ray data? The answer lay in the spectrum. A spectrum reveals an object's chemical composition, its temperature, its motion. The team analyzed BIRD's spectrum using Webb's spectroscopic instruments. What they found were characteristic signatures of ionized hydrogen, specifically the Paschen gamma line, a luminous signature of high-energy processes, and helium, also ionized, also in absorption. These spectral fingerprints told a clear story. BIRD is not a star, not a normal galaxy, but an active galactic nucleus, a black hole consuming material. From the spectrum, the researchers could also calculate the distance, and the result was remarkable. BIRD lies at a redshift of approximately 2.4, that corresponds to a distance of roughly 10 billion light-years. The light we receive today was emitted when the universe was only about 3 billion years old, during what's called cosmic noon, and from the spectral lines, their width, their shape, the mass of the central black hole could be derived, approximately 100 million solar masses. According to NASA data, this is no ordinary black hole, it's a supermassive black hole, one consuming material at an enormous rate. Cosmic noon. Astronomers use this term for the epoch between roughly 2 and 3 billion years after the Big Bang. That's about 11 to 10 billion years ago, measured from today. This period marks the peak of cosmic activity. Star formation reached its maximum. Black hole accretion rates peaked. Galaxies merged. Black holes grew. Then, after this noon, activity declined. Star formation slowed. Black holes became quieter. BIRD exists precisely in this transition phase. At the end of cosmic noon, at a time when certain types of objects were thought to be disappearing, here lies the problem. Since 2022, the James Webb Space Telescope has discovered a new class of cosmic objects, little red dots. Over 300 of these objects are now known, according to NASA publications. They appear as compact red points of light, visible only in the infrared, invisible in optical light. What these objects are remains intensely debated. Some theories suggest they could be a new type of object, so-called black hole stars. Others see them as the seeds from which supermassive black holes grow. The problem? The region around an actively feeding black hole should glow strongly in X-rays, high-energy photons generated by material heated to millions of degrees in the accretion disk. But the little red dots show almost no X-ray emission, almost no radio emission. One possible explanation, proposed in several studies, these black holes are wrapped in thick shells of gas and dust, material that absorbs high-energy X-ray radiation but allows low-energy infrared radiation to pass through. Hidden monsters, masked by their own environment. BIRD fits this picture. With one crucial exception, BIRD is not small, it's bright, it's massive, and it exists at a time when these objects were thought to have already disappeared. The discovery of BIRD raises fundamental questions. First, if little red dots are still numerous during cosmic noon, it means the formation process of supermassive black holes lasted longer than thought. Loiacono's team calculated the space density of these objects during cosmic noon. Their estimate, published in Astronomy and Astrophysics, approximately 4 × 10⁻⁶ per cubic megaparsec. That sounds like a tiny number, But compared to the density of UV-selected quasars with comparable luminosity, it's only lower by a factor of 2 to 3. That means little red dots are not extremely rare. They're a significant population, a population we completely missed until the James Webb Telescope began operations. Second, BARD shows helium absorption lines that are blue shifted. That means gas is moving away from us at high velocity, away from the black hole. Gas outflows at velocities of 830 kilometers per second, according to the publication. These outflows are characteristic of black holes actively consuming material. The radiation pressure is so strong it blows gas out of the galaxy, a process that regulates the black hole's further growth. And third, BARD is not alone. Two other little red dots with nearly identical properties have been identified, GN 28074, called Rosetta Stone, and Ruby's Blagzern 1 point. All three show the same spectral signatures, the same absorption lines, similar masses, similar gas densities. This suggests that BARD is not an isolated case, but a prototype of an entire class. How do supermassive black holes form? That's one of the fundamental questions in modern astrophysics. We know they exist at the center of nearly every galaxy, with masses from millions to billions of solar masses. But how did they become so massive? There are two main theories, according to NASA research. The first, light seeds. Black holes form when massive stars collapse. These stellar black holes, with masses of just a few suns, then merge over billions of years. They grow through accretion, through further mergers. The problem with this theory, it takes time. Lots of time. And the James Webb Telescope has found supermassive black holes in the very early universe, too early for this gradual growth process. The second theory, heavy seeds, black holes don't form from stars, but directly from the collapse of primordial gas clouds, direct collapse black holes. This theory allows black holes with masses of 100,000 to 1 million solar masses to form instantly, a massive head start. BARD and the other little red dots could be precisely these heavy seeds, or their direct descendants, black holes hidden in dense envelopes of gas, black holes still growing, still actively feeding, still accumulating material, hidden from our X-ray telescopes, visible only to Webb's infrared eyes. Today, November 16th, 2025, we know of over 300 little red dots. BARD is one of the brightest, one of the best studied, but it's not the last. Webb continues collecting data. Researchers continue searching archives. New spectroscopic observations are being conducted. With each new discovery, it becomes clearer. The universe we thought we knew is more complex, richer, more surprising. Black holes disguised as red dots. Monsters hidden behind curtains of gas and dust. An entire population of cosmic objects that only now, in the infrared light of humanity's most powerful telescope, become visible. BARD is the brightest example, the big red dot at cosmic noon. But the question remains, how many more are out there? How many more secrets does the universe hide from us? How much have we still not seen?